Our story begins in a nebula, vast, sprawling clouds of hydrogen and helium, the universe's stellar nurseries. These immense regions are some of the most beautiful and mysterious places in the cosmos, glowing with the light of energized gas and dust. Nebulae are where the building blocks of stars and planets are gathered, waiting for the right conditions to ignite new life. Within these clouds, gravity works its magic, slowly pulling denser pockets of gas and dust together over millions of years. The process is incredibly slow and subtle, but relentless, as invisible forces shape the future of entire solar systems. These clumps begin to grow larger, spinning as they contract, and eventually form dense molecular cloud cores, the seeds of new stars. Each core is a potential birthplace, a hidden cradle where gravity and chemistry begin their delicate dance. The dust in these clouds is ancient, forged in the fiery deaths of earlier generations of stars. This cosmic material is recycled again and again, making the universe a vast, interconnected system where nothing is truly lost. From diffuse, wispy gas to dense, star-forming core, this transformation marks the very first step in the life of a star. It's a process that has repeated countless times across the universe, shaping galaxies and lighting up the night sky. The journey from cloud to core is a remarkable one, setting the stage for the birth of a star and the creation of new worlds. Each nebula holds countless stories waiting to unfold. Let's see what happens next, as the cosmic story continues to unfold. As the core of a collapsing cloud contracts under gravity, it heats up dramatically, reaching temperatures far higher than anything we experience on Earth. This process forms a protostar, a hot, dense sphere of gas and dust, still shrouded in the remnants of its birth cloud and hidden from view by thick, cosmic dust. Over time, the protostar continues to grow, pulling in more material, while its core pressure and temperature soar ever higher, setting the stage for a dramatic transformation. When the core finally reaches about 15 million degrees Celsius, a critical threshold is crossed. Nuclear fusion ignites at the heart of the star. In this intense environment, hydrogen nuclei begin to fuse into helium, unleashing an immense amount of energy in the form of light and heat. This powerful energy output pushes outward, halting the core's collapse, and marks the moment the protostar transforms into a true star. The star now enters its main sequence, a long, stable phase where the outward pressure from fusion perfectly balances the inward pull of gravity. Our Sun is currently in this main sequence phase, steadily burning hydrogen in its core and providing energy to our solar system for billions of years. Yet, even stars as mighty as our Sun cannot burn forever. Their fuel will eventually run out, leading to the next dramatic chapter in their lives. Eventually, a star's core runs out of hydrogen fuel. Gravity takes over, the core contracts, and the outer layers expand. The star becomes a red giant, swelling to hundreds of times its original size. Its surface cools, glowing red, while the core heats up. If massive enough, the core fuses helium into carbon and oxygen. This phase is brief compared to the main sequence. The star is burning through its last reserves. The end is near for our aging star. With helium gone, fusion in the star's core comes to a halt, and the once vibrant star can no longer support its outer layers. These layers are gently pushed away, drifting into space to form a beautiful planetary nebula, a glowing shell of gas and dust that expands outward, illuminated by the dying star's last light. What remains at the heart of this nebula is the core, a white dwarf, a stellar ember about the size of Earth, but containing nearly as much mass as our Sun, making it unimaginably dense. White dwarfs are made of electron-degenerate matter, a state so dense that a teaspoon of it would weigh tons on Earth. These remnants are among the most compact objects in the universe. No new energy is produced in the white dwarf. It shines only from the leftover heat trapped inside, slowly radiating away its energy into the cold darkness of space. Over billions of years, the white dwarf cools and dims, its light fading until it becomes a cold, dark black dwarf, a silent relic of a once brilliant star. The material shed during this process enriches the surrounding space with heavier elements, seeding the cosmos with the building blocks for new stars, planets, and even life itself. The cycle of stellar birth and death continues as the universe recycles its stars, forging new generations from the ashes of the old. And so, while the life of a single star ends, the grand story of the cosmos carries on, ever evolving and renewing itself across the vastness of space and time.